We're going to work a problem in energy and power involving a microwave oven and boiling 1 liter of water. We want to know how much time it's going to take to do that. So we're obviously missing some information right now. So let's put a few things up here that we need to know to work this problem. One is we're going to assume the efficiency is 100%. Now microwave ovens aren't 100% efficient, but right now we're trying to get the concepts down, so assuming 100% efficiency is going to make this problem a little easier to work and help you understand some of the concepts involved here. In reality, microwave ovens are probably about 60 to 70% efficient, which means that for any given amount of power coming in, you're going to get a percentage of that power being converted into microwaves to heat food. Okay, so we got 100% efficiency is what we're assuming. Another thing is we're going to talk about a 1200 watt microwave oven, or 12 kilowatts. Both are the same thing. We also need to know what the temperature rise of the water is going to be, and we're going to say that's 80 degrees C, because we're at 20 degrees C for room temperature. And by the way, the units of temperature have to be degrees Celsius for this to work. So we only need a 100 degree water to boil. So if we need 100 degree water to boil and we're at 20 degrees C, we only need an 80 degree temperature increase. Now, we know we have a liter of water, and that's one of the things that's going to impact how long this takes, is how much water do we have. Making it a liter is going to make this problem a little easier to work. And we know we need a 20 degree temperature rise. So we can be pretty certain that these values are going to be, if they're in a fraction, they're going to be on the numerator of the fraction. Because if you increase the number of liters, that's going to directly impact how much time it's going to take to boil that water. And the same thing goes with temperature. If we have a larger temperature rise that we need, then that's going to be directly proportional to how long we're going to have to wait. So we can start out by just saying that we have 1 liter of water on the top of, we don't really have a fraction there, that's actually something that we're starting out with. We're going to multiply this by conversion factors to get what we want. So we need to find something to multiply this by to get started. And one place to start is the fact that when we're talking about water, the neat thing about the metric system is there's a relationship between water, volume, and mass. 1 gram of water in the metric system weighs 1 gram of water has a volume of 1 cc, or 1 cubic centimeter, which is kind of an interesting relationship. So that kind of pulls together volume and mass. Also, another thing that pulls this together is the calorie, because one calorie is equal to 1 degree C times 1 gram. It's the product of these two things. If you raise water 1 degree centigrade, 1 gram of water 1 degree centigrade, it takes 1 calorie of energy to do that. Also, we can have 1 kilocalorie, which is equal to 1 degree C times 1 kilogram, or 1 degree C kilogram. This actually is going to help us here a little bit, because there's also a relationship that says 1 liter of water weighs 1 kilogram at standard temperature and pressure. We're not going to get into the fractional amounts here, because there is depending on the temperature and pressure, this is going to change, but we're close enough to standard temperature and pressure here to where we're not going to worry too much about this particular equivalency here. So we've got 1 liter of water, and we're really going to need kilograms to be able to find calories, because we're going to work from calories over towards joules and ultimately kilowatts. So we can come up with an equivalency that says that 1 kilogram over 1 liter is equal to 1, since 1 kilogram of water weighs, or 1 liter of water weighs 1 kilogram, and 1 kilogram of water occupies a space of 1 liter. So this is going to help us cancel out our liters while we're working on this. Another thing we can do is relate the kilocalorie to the temperature we're going to need and the amount of water that we have in kilograms. So we can come up with an equation that says 1 kcal over 1 degree C 1 kilogram is a conversion, because 1 kilocalorie is the same as 1 degree C, 1 degree C temperature rise of 1 kilogram of water. This is going to help us cancel out our kilograms here. Okay, now we need to start looking at the kilocalorie and its relationship, and it turns out that when we're converting kilocalories to joules, which is really what we want to be able to come up with, there's 4,200 joules per kcal, and that's 1,000 calories. Okay, there's 4.2 joules per calorie and 4,200 joules per kcal. So this is going to help us cancel our kcals and end up with joules. Now what else can we do here? Well, we know we got a 1200 watt microwave oven, but what does 1200 watts mean? 1200 watts really means 1200 joules per second. Okay, so we've got a conversion factor here that's going to relate joules to seconds, which is what we're really looking for here. It's one of the things that we really need to know. So let's try something here. 1200 joules per second is the same as saying 1 second is equal to 1200 joules. And this will allow our joules to cancel out nicely and give us seconds, which is what we're looking for. But we still have one more thing to do here, because if we go through cancellations and take a look at them, we've got joules canceling out, we've got kcals canceling out, we've got kilograms canceling out, we've got liters canceling out, but we're still left with seconds here, and that's not what we want. We don't want seconds in here. We just want seconds. We don't want degrees C in here, I should say. We want seconds. So we've got to find something to multiply this by, and really that's our temperature increase. If we want to raise the temperature of this water 80 degrees centigrade, So if we multiply this by 80 degrees C, that's going to allow our centigrades to cancel out. We've really got just a couple of things to do here. We've got to divide 4200 times 80 by 1200 joules. And with our calculator here, we're going to enter 4200. We're going to multiply that by 80. Everything on the top, the numerator, we're going to multiply together. And that gives us 336,000. We're going to divide that by 1200. And that's going to give us 280 seconds. And that's our answer. Now, let's find out how many minutes that is. So if we take 280 seconds and divide it by 60 seconds in a minute, that gives us 4.6 minutes. Which is our answer in minutes. So that's it.